In this lesson, I'll show you two examples on how to find the area between two curves using integrals. This is part 3. If we must find the area bounded by two curves, and if the limits a and b are not given, we must solve the given equation simultaneously to find their points of intersection. So you'll notice that in both of these questions, questions 1 and 2, we're not given a lower and upper bound. So starting with question 1, we're asked to find the area bounded by the parabola y is equal to 2 minus x squared and the straight line y is equal to x. We have to first set these two equations equal to each other to see where they intersect. So I'll use the substitution method. I'll substitute this y with x, where I end up with x is equal to 2 minus x squared. And now I need to solve for x. This looks like a quadratic equation, so I'll first take this term over to the other side, leaving me with 0 is equal to 2 minus x squared. Now I will rearrange this so that it is in standard form. Now it's in a format that makes more sense to me, that's more recognizable. What two numbers multiply to negative 2 and add to positive 1? Positive 2 and negative 1. So this factors into x positive 2 and x negative 1. Therefore, our x values here are x is equal to negative 2 and x is equal to positive 1. Next, we have to determine which of these two functions is the upper and lower function. So the one that's upper will be the one in which we subtract the other function from. If you graph 2 minus x squared, you'll end up with a parabola that's upside down. And if you graph y is equal to x, you'll end up with a straight line passing through 0 and 0. I know it's hard to envision without a visual, but this would be the upper curve and this would be the lower curve. Now that we know that, we can use this formula to find the area, where area is equal to our bounds, 1 and negative 2. So I'll put negative 2 down here and 1 up here. And I'll subtract this function from this function, 2 minus x squared minus x dx. By taking the integral of this function, I've found the area bounded between these two. Let's go ahead and do that. The integral of this term is easy. It's 2x. The integral of this term is minus 3x to the power of 3 over 3. And this is minus x squared over 2. And now I'll evaluate this at the upper bound first and then at the lower bound. Let's start by substituting 1 into each of these terms. 2 times 1 is 2. 1 to the power of 3 over 3 is negative third. And this is negative half. Minus, now I'll evaluate this function at negative 2. 2 times negative 2 is negative 4. Negative 2 to the power of 3 is negative 8 times negative 1. That gives us 8 over 3. And negative 2 to the power of 2 is positive 4. This minus makes it 4 over 2, which is 2. I'll plug this into my calculator. Let's see what we get. This gives me an area of 4 over 5, or 9 over 2. The area is 4.5 units squared. Let's move on to question 2. In question 2, we're expected to find the area bounded by the curves y squared is equal to 12x and y squared is equal to 24x minus 36. For this, I've provided a visual. Now, we need to find out the points of intersection, so I'll set these two equations equal to one another. Notice that we have y squared here and y squared here. So I'll set 12x is equal to 24x minus 36. This looks like a linear equation, so I can easily solve for x. Bringing that over, I get 12x minus 24x is equal to negative 36. That becomes negative 12x is equal to negative 36, and therefore x is equal to 3. And that shows in the illustration here. Notice that we have 3 here and 3 here. I'll take a different approach to this question to find the area. Oftentimes, the use of horizontal elements as opposed to the vertical elements that we used here, by using the x-coordinates, we were using the vertical bounds. Sometimes using the horizontal elements will make our work easier. So what I will do is find out the area of this, and since they are perfectly symmetrical, I'll find out the area of this and then double it by multiplying it by 2. However, to do that, I'll need to write both of these equations in terms of y as opposed to in terms of x. I'll start the process by solving for x in this equation, and I can easily do that by saying y squared over 12 is equal to x. That's my first equation. And for here, I'll bring this negative 36 over and divide both sides by negative 24. So I'll have y squared plus 36 divided by 24, and that gives me my x value. According to this visual, this is my upper curve and this is my lower curve. So what I'll do is subtract this from this. And also what I have to do is find the lower and upper bounds along the y-axis. To do that, all I do is take this number and place it into any one of these equations. If I take 3 and place it into this equation, I end up with 36, and the square root of 36 is plus minus 6. So after subtracting these two, and since I said my strategy was to find the area of this and then just multiply it by 2, the area for the upper part of these two functions will be between 0 and 6. And now I have to subtract them, dy. Now I'll take the integral of each of these terms individually. This becomes y to the power of 3 over 24 times 3. This becomes 36 over 24 y. And this term integrates into y to the power of 3 over 12 times 3. A is equal to the following. Now I can evaluate this at 6 and 0. Evaluating this at 0 makes it 0, so don't worry about that. We'll have to find out what this is equal to when y is equal to 6. And then multiply that by 2. So starting with this term, 6 to the power of 3 is 216 divided by 24 times 3. 24 times 3, that gives me 3, plus, now we're here, 36 times 6 divided by 24, minus, and finally, this part, we have 6 to the power of 3 over 36, because 12 times 3 is 36. And that gives me an area of 6. This area right here, from here to here, is 6 units squared. Multiply that by 2, we get 12 units squared. There you have it. 2 examples on how to find the area between two curves using integrals.